Alright guys, my name is Eric Wheatley, and today I'm going to be going over a couple examples of the limit definition of the derivative. This topic gave me some trouble when we first learned it, so I decided to spend a lot of time looking at it this time around because I do not want to get it wrong in the final exam. So because I realize these are all kind of quick to explain, I decided to do 3 different problems. That way I can give you guys just more examples of the process. So the first one I did was number 23 from the final exam review, and that question was, let f of x equal to 2x squared minus 3x minus 1. Use the limit definition of the derivative to find f prime of x. And below that, right here, I've got listed the limit definition of the derivative is equal to f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And I don't know if you guys remember, but back when we first learned this, Professor Seeberger said that he has a lot of students make the mistake of right here, they mess up this part of the process. They somehow incorrectly substitute x plus h for x, or they don't do it. So this very first part of the process, you want to make sure you set yourself up correctly and carefully insert x plus h wherever you have an x in f of x. And then as you can see, I just go through and I slowly simplify all the terms. I don't try to do too much in every single step because as I learned when I was doing this, I made a couple mistakes. So slowly you want to simplify each term and not do too much each step. And what you're trying to do is reduce it to a simple enough term or expression where you can plug in 0 for h and get an answer. So as you can see, I simplified it to the point where I got f prime of x is equal to 4x minus 3. And my proof was just using the derivative rules that we learned later after the limit definition of the derivative. We can see that that is in fact the correct answer. Alright, so the next one I decided to do was question 24 from the final exam review, and that was to let f of x equal to radical x plus 5. Use the limit definition of the derivative to find f prime of x. And once again, I've got the limit definition of the derivative listed, and just again that reminder right here of plugging in x plus h wherever you have x. Now this one is a bit more tricky. To get rid of this ugly term right here in the numerator, I decided to multiply both the top and the bottom by 1, or rather, the conjugate of the numerator. And as you can see, I again slowly simplified this because I also made a mistake on this one when I was going through it. So you want to slowly simplify all these terms because there are a lot of them. But you're working to get to a point where you can plug in 0 for h, or direct substitution, but you can't do that until you get down here. And the answer I got was 1 over 2 times radical x plus 5. And then over in the bottom right hand corner, I have the proof of that. F of x can be rewritten as x plus 5 to the 1/2. And then just using the chain rule, actually, you get f prime of x is equal to 1/2 x plus 5 to the negative 1/2 times the derivative of x plus 5, which is just 1. Rewriting, we get f prime of x is equal to 1 over 2 radical x plus 5, and we can see that that checks out. And the last one I decided to do is number 25 from the final exam review, and that question was, let f of x equal to 5 over x minus 3. Use the limit definition of the derivative to find f prime of x. One more time, limit definition right here, and again that one reminder. This one was a lot to write down just because we've got a fraction and a fraction, so just one more time, slow down with these and be fully aware that you might make a mistake if you rush the simplification process too much. So to get rid of this ugly fraction and a fraction, I multiplied both the numerator, well, I multiplied the fraction by 1, but what I really did was I found the least common denominator in the numerator and multiplied both the overall numerator and the denominator by that. And that was that got rid of that ugly fraction in a fraction. And then again, I just slowly simplified the limit, because as you can see, there's a lot of terms. And I'm just simplifying it carefully to get to a point where I can plug in that 0 for h. And as you can see, I get an answer, f prime of x is equal to -5 over x squared minus 6x plus 9. We can rewrite that, or just another form of simplifying, as -5 over x minus 3 squared. And over here is my proof of that. You can rewrite f of x is equal to 5 times x minus 3 to the -1. Again, using the chain rule, bring that -1 down, you get -5 times x minus 3 to the -2 times the derivative of the what's inside, which is just 1. Then rewriting that, you get -5 is equal to x minus 3, -5 is equal to x minus, one more time, -5 over x minus 3 squared, which is what we have, and as we can see, the proof checks out. So the biggest thing to note when doing any problems where you have to find the derivative using the limit definition is to remember to slowly and carefully plug in, for this part where my mouse is right here, x plus h for all values of x in f of x. So you want to be really careful when you do that, and then just don't rush when you're simplifying, because there's just lots of little terms, lots of signs. You're going to think it's easy, and you're going to rush, and you might make a mistake. You might get a sign wrong, and then that'll impact your answer at the very end. So slow down in this step right here whenever you're plugging in x plus h for x, and then just slow down over the entire process. And it never hurts to just double check your work by doing a proof with a newer derivative rule that we do know now. Alright guys, that was my presentation of 3 limit definition of the derivative problems. Thanks for watching my video.